Okay, now we're going to move on to a sample means question. We have a bottle company uses a filling machine to fill plastic bottles with cola. The bottles are supposed to contain 300 milliliters. In fact, the contents vary according to a normal distribution. So they're telling us it's normal, with a mean of 298 and a standard deviation of 3. So from the problem, this is what we know so far. It's a normal distribution. 298 is the mean, and 3 is our standard deviation. So we're going to hold on to that. Part A says, what is the probability that an individual bottle contains less than 295? If we're only picking an individual bottle, we're not really using, it's just one, it's one item. We don't have to go through the conditions. We can just go and check the probability. We know it's normal, so we don't have to worry about anything with that as well. And this is the information that we're going to use. So we want the probability that the bottle X bar is going to be less than 295. So we need to calculate a z-score for that, so we need to standardize it. 295 minus 298, which is our mean, divided by the standard deviation. We're going to wind up with a negative 3 over 3, which is a negative 1. So my answer is going to be the probability that z now is equal to a negative 1. We go to the table and we look up a negative 1. So flip it over. We go to negative 1, 1.0, 15.87. And so that probability is going to be 0.587. And we're done. Okay, part B. Part B says, what is the probability that the mean contents of the bottles in a 6-pack is less than 295? All right, so now we have 6 bottles, and we have a definite probability question in which it's a sample means question. So we have conditions that need to be met. So the first condition is it needs to be an SRS. And this is where we had a problem in class because it doesn't say it's an SRS in the problem, but we're picking a 6-pack. So we can assume that we just picked that 6-pack up off the shelf, that those bottles were randomly assigned to that 6-pack, so we're good. Okay. Number 2, we're supposed to know that the distribution is either normal or that n is greater than or equal to 30. Well, we wouldn't have satisfied this because we're only dealing with 6, but we do know the distribution is normal because it is stated in the problem. Okay, and we are going to use, or condition 3, sorry, standard deviation is known. And this is the population standard deviation. And that's known. And once we know that that's known, then what we're going to do is we're going to be using the standard deviation that's given to us divided by the square root of n to find out the standard deviation that we're going to use in our problem. Okay, so this is what we know for B so far. We know that the distribution is normal. We're going to assume the mean is 298. And our standard deviation is going to be the given standard deviation, which is 3, divided by the square root of our n, which is 6. And when we do that calculation, we get 3 divided by second square root 6. And we're going to wind up with 1.225. All right, so now we want, what is the probability that it's less than 200? So same type of question. X bar is going to be less than or equal to 295. So this is going to be the probability that the z-score is going to be, now that's going to change. So the z-score is equal to, and now we're going to have to standardize this. So our z is going to equal 295 minus 298, that's the same, but our standard deviation now changes to 1.225 that we use for the problem. So we're going to get a negative 3 over 1.225, and that's going to equal negative 3 divided by 1.225. We're going to get negative 2.45. So my answer, or the probability I have to find, is the z-score is going to equal to negative 2.45. So when I go ahead and look that up again, you're going to go to your z table, negative 2.45 So negative 2.4, you go over to 5, 0.0071. .0071. All right. And again, looking at the two results, when we deal with a single bottle, given a normal distribution, we have a 15.87% chance of finding that bottle. But when we're given a six-pack, and we look at the average of those bottles in that six-pack, the probability of finding a six-pack with the same average now of less than 295, we have a less than a 1% chance of finding it. So this is telling us very, very difficult to find that six-pack, if not nearly impossible. And to find one bottle, we have a 15% chance.